Greetings everyone. We are the students of VNIT, Water Resource Engineering, and today we are going to show an experiment based on the flexural strength test of a concrete beam. Now, the flexural strength, also known as the modulus of rupture, bend strength or the fracture strength, is a material property defined as the stress in a material just before it yields in a flexural test. The flexural strength represents the highest stress experienced within the material at its moment of rupture, and it is measured in terms of stress. The units are MPa, megapascal. To overcome this type of failure, the main steel is actually provided at the bottom or the top of the beam, and the flexural failure occurs at the midspan of the beam. There are many causes of flexural failure. The flexural failure is governed by concrete crushing after yielding of the steel. Indeed, the deformation capacity of the steel is normally not crucial, because steel is a ductile material and concrete is a brittle material. Now this diagram shows how the flexural failures occurs, and the experiment setup is like this. It is called a 3-point loading, where the span length L is here divided into 3 parts, L by 3, L by 3, L by 3, to create a moment of pure bending. Now we will see the mixed design calculations. Now here the first step will be we will calculating the target strength. Then the second will be water cement ratio, water content, cement content. Fifth step we will be calculating the proportion of coarse aggregate to 5 aggregate, then the volume of coarse aggregate and fine aggregate individually. Then we will calculate all the 3 components individually. Their masses is known, and then we will proceed of size 0.5 into 0.1 into 0.1 meter. Now this is aggregates, fine aggregates. This is the beams, mound. This is the cone for testing slump. This is the tamping rod. This is the mixer. This is a vibrator, and this is our testing machine. Now first we have to tighten the beam so that there is no bleeding. Then we take coarse aggregates with the weighted amount that we calculated in the mixed design. After taking the coarse aggregate, we weight the fine aggregates with the amount that we calculated. Then cement, we weight the cement, and then we weight water. Whatever water is required, we just weight it and take it. After that, there will be a process of dry mixing. That is, we put all the contents in this mixer. Like here we are putting the sand, the coarse aggregate are already there, and then this will be the process of mixing. Then we will give a small dry mixing by putting the cement also, and then we will switch the mixer on. Now we start the machine. As we see here, the mixing has started. Now we start the mixer, and after a point the dry mixing is complete. Then what happens is we start adding water to it. Now and then further. Then after the concrete is prepared, we will be doing a slump test. For that we will be giving some tamping rod help into the slump and giving some blows. Then we will slowly remove the cover of the slump to check what is the slump there. So as we can see here, the slump here is a true slump. That is, the shape of the slump is not much deformed. Then we calculate the difference of the height between the two cones. Now, Now after 20 days, 8 days of curing, what we do is we will be testing the beams in a cube, in a lab. As we see, due to the 3-point loading, this beam has failed. Now there you can see a wooden plank is there, and that is to ensure a uniform distribution of load, to ensure the pure bending. This is the third beam, that 3 beams we have casted and 2 have failed, and this is the third beam. So results we know, or to be more precise, the flexural strength of the beam is 4.5 MPa. Thanks a lot.